Oh yeah, so I lost that file, but that's okay. Have to reset this. So a good indicator, a really good indicator of a good company is that when you as an employee feel that they care about you in terms of your training, your development as a professional, uh, uh, caring about your own input, your feedback on things that are going on, your participation in meetings. If you find that everybody is isolated and only, elite, uh, selected set of people meet and talk about important things, this is not a good company. A good company needs to be quite open and sharing ideas. And again, if you feel that it's not taking place, if people don't get enough training, if people don't get recognition for what they do, and there could be also company-based training that people train one another, have those monthly or whatever events, user conferences, similar things, then my take on that is not a good company, right? So now another view of this is that you can hire more expensive people who are designers, who are like software architects, that they really kind of good at architecting things, but at the same time they should not be burdened by writing any code. So there's like, smart people out there who really know how to connect the ends, know how to talk to expert users, and they provide ultimate designs that all you need is those coders who get the design and just basically you send an email, I want to design this class, and go ahead and do the work. So the designers, if they don't do the coding, if they don't deal with the day-to-day operation, regular programmer, what comes out is that it's basically almost always could be an oversight system with poor performance, right? And I would say that this government website that we have, the healthcare, the Affordable Care Act, healthcare website, it definitely has the signs of something like this happening, where it's basically, it seems to be pretty large, and it also seems to be having, besides other problems, also have poor performance because people are reporting a long waiting times to, for things to respond. I don't know if it's a scalability issue or it could be some bottlenecks that exist in that software. But certainly that particular example clearly indicates that there were some really gaps in the work performed, that the system wasn't designed properly and wasn't implemented properly either, right? But I mean, over time, of course, it's going to get better and it's going to get to from its knees and start working. But that those things really do exist in real life, right? So something is amiss. People very important, and people play very, very important role. And I think all successful companies provide, trying to make people happy, and that's important in this business because programmers are very smart. Sooner or later, if they realize that something doesn't work properly, they will move on. If you try to enforce some unusual or non-working solutions on them, they will find workarounds. It's just I would say that the entire team, the entire project team, has to feel that this is a healthy environment. Then the work is done well. All right, and so I guess a few more things about this. A system cannot be built without a formal design, and I would say that to me, the measurement of how much formal design you need to have. And when I say formal design, it's pretty much everything outside of the code, anything outside of the source code. I would say the formal design has to be proportional to the complexity of the system that you're trying to build, right? If it's like a 2-day project, so just on a scrap of paper, you can, draw a couple of diagrams and start with that. If it's a, more complex project, perhaps you have to maybe hire a technical writer who know, people who really know how to produce the documentation properly and are good at that type of work. So it needs to be proportional, but it still is very important. You almost never, yes, in some cases, you can just sit down and write the program from scratch and make it work and say, okay, I'm happy with it. But most of the time, especially when taking new unfamiliar tasks, design, step number 1, right? So we talk about the iteration. So examine the problem, create an overall design, find standard components. Very important is that if your programming language already has associative containers such as maps or hash maps or some other types, don't write them from scratch. You should find existing components and use them, right? Would be another example would be, don't write a database from scratch based on some storage in the file. You can use already existing databases, and they have great performance, great transaction support, right? Something the database is where you make your system reliable, so that even if the computer crashes or the power goes down, a good database will still be able to reestablish integrity of the data, and by the end of the day you can restart your application and have it in good state again. So anyway, find components that already exist and don't reinvent the wheel, right? Then also sometimes recognize that you may be reusing some components many times in your system. So then don't copy and paste this loop multiple times. Instead, create a class which is responsible for something that you will be reusing many times in the system. So you create your own standard components and then reuse them, right? And then finally, once you decide what's in place, assemble the design together. So sometimes you may also strive to the condition that we call universality. Basically, take a group of classes or one particular class and make it look like it's universally designed. It's just like absolutely complete in terms of what it can do or in terms of what anyone could ever need from it. This is perhaps, a very non-productive approach. I would say instead of aiming at universality, just aim at practical, by the end of the day, what do I need to have done, right? I need to have this class done. I want to start testing it with other components. So chart a reasonable working solution and just at some point say, this is it, let's start with it. If some changes have to take place down the road, we'll come back. It's an iterative process. So don't kind of struggle with this idea that it still doesn't look right. No, we still need to tweak it. Let's just think about yet another scenario. This is completely unnecessary. This is not the way software is written. You cannot write the entire system at once. You always will be choosing critical parts of the system and say, let's write this part of the system. And there, this design that you have needs to fit that task at hand. And That's it. That's the measurement for it. So one reason the development cycle is a cycle is that it's essential to have a working system from which to gain experience, right? So you do, each iteration gives you more experience with what you have, what you're trying to build. So that's the approach, not aiming at universality of any sort.